Hey guys, Tom Cherry Holmes here with Errata Online and the FujiNet project. We have right here test number 22, which is demonstrating the usage of the SIO interrupt line to avoid excessive SIO polling. Now the astute watchers amongst all of you may notice that there is no test 21 yet. That's because while I have written test 21 and have tested it here on my own system, it requires another tester or two before we can actually take and make a video on it, because it's a tic-tac-toe game and it will demonstrate UDP packets. So expect that video to show up in the next week or so. Until then, I've moved ahead to work on testing to make sure that the interrupt line is working as expected. On the FujiNet side of things, we essentially add a couple of checks inside of the main loop, which determine whether or not a client, if a client is actually available and connected, and there's data sitting on it, then we go ahead and take and wiggle the interrupt routine. Pull it low, then pull it back high again. This is just for testing. We'll see what the best behavior actually is. And we do the same thing for the SIO server if it's actually active as well, so we can check for connections. And to exercise this, we actually have my Atari running here, but we also have a little C window over here on the right-hand side, which we will use to use Netcat to do a connection. So with that, let's go ahead and turn on the Atari, get it configured. We see our configuration program. Okay, and now that we're done, we boot into our test program. Well, almost. I need to add an auto run functionality here, but we'll go ahead and just load the test program so we can have a look at it. As you can see, it's only a few lines long, and we'll just kind of go through it here. The interrupt line is actually connected to one of the PI interrupt lines. In this case, it's connected to PBCTL. And in order for us to be able to detect whether or not that interrupt drops or not, whether or not that line will drop to low, we need to enable that interrupt. And we do that by poking bit 1. Now normally 54018 and 54019 are set to 60. If we go ahead and turn on bit 1, that becomes 61, that enables the interrupt. And at that point, we subsequently go ahead and accept a connection. We set up a listener. And at this point, we're waiting for connections. If we look here, you'll notice that we're not polling for a connection. We're not sending an SIO request, doing a status command, asking for a connection. So you won't be hearing a tip, 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 as it tries to take and poll to ask for the status of a connection. Instead, what we're doing is we're looking at bit number 7 of the aforementioned register. And in this case, if it's set and the final value is 188, then we accept the connection and go forward, at which point we can do an XIO 97 to accept the connection. This is important because quite literally, if we try to accept a connection and nothing comes, then 97 will time out. And this really isn't desirable. We want to actually accept the connection if there's actually one to accept here, so we can use the interrupt facility to poll and check for that. Once this is done, the value actually will clear itself from bit 7, but bit 1 will also be, bit 0 will also be zeroed out as well. So if you want to check for that interrupt again, you have to reset and re-enable that interrupt. This is not a behavior of the operating system, but it is actually a behavior of the PIA itself to act as a mechanism for acknowledging an interrupt and pulling it back up again. It kind of helps you along in that way. So, with that, go ahead and run. And we wait for a connection. Notice how quiet that is. Nothing happening. Don't hear any tup, 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 tup. That's because it's just sitting there looking at that interrupt line. The moment that we flip that interrupt line, by accepting a connection, yeah, alright, well, never mind. You're not going to do it. There we go. Slight bug there. But you can see that we've now accepted the connection, and it'll go back and forth. Now, this is proving that the interrupt line works. What this is also telling us here too is that we need to refine how these interrupts are serviced and what's the correct thing to do in all of these in various edge cases. And this will be worked out in future tests, but I wanted to go ahead and record this for now so you guys could see. Until next time, guys, have fun.